Hello community, so great that you are back. Our friends in China further developed the R1 model, so let's have a look what's cooking. Now, you know DeepSeek R1, an outstanding model, a beautiful reasoning model with some perfect performance thanks to the GRPO. It's policy optimization that is a group relative policy optimization as published in this paper, and it is now GRPO more than 1 year and 2 months old. Great. Yesterday at NVIDIA, you know that we had here Jensen telling us about the pre-training scaling, the post-training scaling, and the test time scaling, the long thinking, and we move now from an agentic AI to a physical AI. Now let's stick with this, and here you have the article in TechCrunch, and we have a new GR00T N1, a new foundation model in AI for humanoid robotics. So you understand we need some multimodal systems because just a reasoning system here on language is not enough for the future of AI. So therefore, simple, no? Let's have a look at R1. We just want to have R1 now extended here to vision language models. So therefore, we have to take GRPO and we have to find an extension here for the multimodal world. So seems to be easy. Let's start. Now, thankfully, yesterday we learned to get new hardware, NVIDIA DGX Spark. And if you have a look at this, this is it. Isn't it cute here? And if you look at it, just 128 gigabyte here of unified memory. Now, this is not enough for what we want to play with. So we have to go here with the ultimate desktop AI. And you can go to NVIDIA and say, notify me whenever it will become available sometimes in 2025, hopefully. And if you look here at the specs, yeah, this looks better, no? GPU 288 and CPU up to 496 gigabyte. This looks nice. But unfortunately, it's not available. So in today's video, we have to do something. We cannot work with the full-fledged R1, with the huge one, but we have to scale it down a little bit to a smaller R1. Well, okay. But we will stay on focus. We look for multimodal language models. And we have image, video, audio, or think about LiDAR, point clouds, or whatever you have. So whatever is a different modality here, I think primarily will be a video and audio. We have to build those systems for robotics. Now, great. So let's build this, né? And we have a new study, and I show you here a new research team, and they wanted to build an R1-like outstanding capability model with a step-by-step long chain of thought reasoning capability, and now they wanted to build this simply for multimodal AI models. But of course, to explore this, to experiment with this, implement all the new ideas, they could not afford to go with a huge R1 model, our friends in China, but they used here a smaller R1 model. Well, of course. So they decided they go here with an R1 7B for here this vision language implementation. Now, careful. If you read the study carefully and you have a look at the video where I showed you here the new Light R1, they did not know about the Light R1 because they have not watched my video from days ago. And I thought they went with an R1 distilled version, no? Because I showed you in this video, beautiful, we have here the base model, a QN 14B, and then we just distill here the long reasoning traces down from the huge R1 model, no? But then, reading this, I noticed that they actually went here with the QN2 VL7B model, which is interesting. At first, it is not the latest here from Q1, because currently, if you look here at Q1, we have a Q1 2.5. But I think you don't want to show here new latest algorithm on the latest model, because, yeah, there's a little bit of competition, no? That's always good. So, why this video? Because there's something new going on in the world of AI research, and I just want to show you where we are jumping. And this is really in parallel with what Jensen told us yesterday. We are moving here in a new direction. Now, you know, short history, DeepSeek R1, beautiful. Power was primarily here on GRPO, but lies an online reinforcement learning here without the need for a complex reward model. Because GRPO in DeepSeek R1 encourages an LLM to generate a group of reasoning paths and iteratively refine its reasoning process by rewarding here the generated reasoning path based on a rule-based reward function. So no AI model, simple rule-based function. So second was, we were working with an outcome level reward strategy. No? All the reasoning paths leading to a correct answer that were finally validatable received higher rewards, while those leading to the incorrect answer received lower ones, the classical one. And now the question is, okay, so we have this GRPO in DeepSeek R1, our reasoning models, and now you want to bring it over and extend this to multimodal models from LiDAR, audio, video, whatever you have. Now you remember, currently we have in our multimodal LLMs, we have more or less a limited reasoning capability because we don't have this R1 really implemented now on multimodal. And those that are implementing, they rely on supervised fine-tuning. But this is not really great because this has a rather poor generalization and a limited understanding of reasoning failures, especially from long chain of thought. So therefore, we do need some reinforcement learning. Now, in the video yesterday, I showed you, yes, exactly. Yesterday, we were talking here about a new development, and I showed you from our 3 training data sets that we needed. Yes, we had a contrastive pair, and this really enforced here the internal reasoning beautifully, and we're working with a contrastive loss function, but in multimodal, we don't have it yet. There's another topic I want to stress, because if you look at the original DeepSeek R1 distilled QN7B from DeepSeek as published, they have a base model that is the QN2.5, luckily the latest, but the mathematical model. But for vision language, turns out, well, we need a general model and not a mathematical specialized hypertrained model. So in this case, I now understand why they did not went with the base model, the QN7B, the distilled version, and reasoning patterns of the larger model can be distilled into the smaller one, so they take here the full reasoning traces of R1 and bring it down here to a QN7B and call this the DeepSeek R1 distilled QN7B. But we want to do something else, yeah? Because we want to go now, if you want, the exact reverse way. We have a base model, a vision language model, beautiful, but we want to make this model now hyper intelligent. So we want to have long reasoning traces, really intensive, but a multimodal question and answer parts and everything now included. So what we do, we take those models here, also from Q and our Chinese friends, and we apply now from R1 the GRPO. Now it turns out we cannot go just for the plain GRPO because we are now working multimodal. So we are now developing something new, what we call a STEP-GRPO on this particular base model for going multimodal. And we will develop here today, if you want, a DeepSeek R1 kind of version model with an extended vision language model for multimodal on a 7B. But to be absolutely clear, this is not from the company DeepSeek, the R1 VL, because I guess this will be the R2 model that might be released sometime soon, so I better hurry up with my video. This is just given here the GRPO from R1 and given the reasoning traces from R1 for the long chain of thought reasoning. We use the ingredients of R1 and we try to somehow build here a multimodal R1, but this is not from the original company, this is here from a different Chinese research group. So they're experimenting here how to modify GRPO, push it into the multimodal world. So let's open up the video. My goodness, this was the introduction. I have to hurry up. Okay, so multimodal language model policy P data generates here step-by-step reasoning actions. See my last videos. An action represent here generated reasoning steps, thus turning reasoning into a reinforcement learning sequential decision-making task. If you want to know more, this is exactly the topic of my last video, so we continue. Now what we have a problem, yeah? Because, this GRPO here suffers here from a sparse reward issue on multimodal LLMs reasoning, and especially on the learning phase. And this is now not good because we do have a suboptimal performance for our multimodal models. And especially if we go with smaller ones, the 7B, the 14 billion models, we have a very limited reasoning capability, especially for the long chain reasoning accuracy and validity. So another point is here, not only the sparse reward problem, but we have an outcome level reward problem. No? Because we just take the outcome and we do not have a process reward model. So we need something better, we need something new, and here comes the solution by the new research team that we have a look at today. So they say, hey, easy. We go the next simplest step that we can think of from our group relative policy optimization. We build now a novel reinforcement learning framework for a dense stepwise reward structure. So we call it here, going stepwise, STEP-GRPO, and we will implement this with two different reward functions that are real easy. So let's see if it works before we have a deep dive. So you have here in the dashed line, this is here the GRPO, the classical one. You see if we apply this here, it goes down. But if we take here the new algorithm, you see both lines here go up. Yeah, either in blue you have the reward or in orange you have the accuracy. So you might say 10 points is not enough, but yeah, this is just an experimental phase and more about this in a minute. So we need a spark of genius and here we are. We do more or less our classical way. StepGRPO, we have two stages, no? We have the policy warm-up phase if you want. We have a classical supervised fine-tuning on multimodal chain-of-thought reasoning datasets to acquire here this basic reasoning capability in the multimodal world. If, for example, I show you an image of whatever, and then I ask you a question, a text, and then this AI model is able to understand the image, have a relation to the text, does a reasoning on multimodal reasoning sequences. And then, of course, we have our policy optimization phase, our reinforcement learning. We need this. So we have now, again, since we go here with GRPO, we have a group of reasoning trajectories. We stay with this methodology, with the core of this methodology, and we say each trajectory receives now a dense reward using two newly introduced stepwise reward mechanisms. And we have a stepwise reasoning accuracy reward and a stepwise reasoning validity reward. Sounds complicated. It is so easy. You're gonna laugh about how easy this is. So the first one, the StepGRPO, simply has here incremental rewards proportional to the correct intermediate reasoning. So this reward function just looks here at the reasoning chain and says, yeah, this looks good. This is exactly here. We should have here this chain of reasoning going on. I'll give you an example in a minute. And the second one here, the RVR, is logical coherence, rewarding structured and logically consistent reasoning paths. And you'd say, hey, this is simple. So the system just looks at it and says, yeah, that sounds like logically deducted. Yeah, that's all there is. This is the simplest step. This is the first step only, yeah? But we just want to go a little tiny baby step here to multimodal GRPO. So, core idea, easy, no? With this StepGRPO, we stay true to the core of GRPO from a group relative optimization. We calculate an overall reward by aggregating now the stepwise accuracy and validity reward functions. The advantages of the reinforcement learning are computed, I'll show you this in a minute, relatively within the group of the sampled reasoning path. Then we have the classical normalization of the rewards and optimizing the policy models through group relative policy optimization technique. I'll show you the loss function in about 2 minutes time. And then we use a Kullback-Leibler divergent regularization to prevent the model divergence from the reference policy. And you know this, no? The difference between drifting, a probability distribution, or a good old friend, Kullback-Leibler. So that's it. Let's go to the facts. Here's the study, March 17, 2025, from Nanyang Technological University and Tsinghua University. Hello to China. Beautiful paper. And here we have it. R1, we are learning to reason with multimodal large language model via stepwise group relative policy optimization. So we stay within the world of R1 of GRPO, and now we make this try to experiment to make this jump, the first jump to vision language model, but based on the R1 methodology. Great. So what we want a model that is kind of self-improving the reasoning via a simple, effective, and a dense stepwise rewarding. So let's have a look at this. Yeah, this is the official thing here. If you want to go there, beautiful. This is just what's happening. We have two reward functions, the reasoning accuracy and the reasoning validity. And then the rewards are calculated and the advantage, the group advantage is calculated. This is put forward to the loss function and this is calculated. So it is the classical mathematical calculation that I showed you so often. Now we're just interested here in this particular reward function because we kind of go for a progress reward model, yeah? But it's a rule-based one. So let's have a look at StepGRPO. So if you want to do the calculation, real easy. The only thing you should remember, there is a beautiful trick here in the reward assignment. And yes, of course, you have 0 if no steps match or no answer is provided. And if you have a final answer is correct, you have the classical 1 plus a parameter. But there is also here, if the intermediate steps are partially correct and just the final answer is incorrect, but in a long chain of reasoning, you see that there are some correct parts, but unfortunately somewhere in, I don't know, level 7, suddenly you make a mistake. The system now looks at this and gives you here not just a 0 or 1, but has here partial reward matches. And this is nice, because now the model receives a then feedback even when it fails in the end to provide a correct final answer, but thereby significantly mitigating here the sparse reward problems inherent to an outcome level reward. So this is a nice and so simple trick that we say, you know what, let's have a look. These intermediate steps here are they partially correct and can we award them a partial reward. RVR, the reasoning validity reward, now it is even simpler. We just look here if it includes the necessary structural components. This means, hey, the AI looks, does it include a logical sequence? And the easiest logical sequence is the background analysis, a step-by-step intermediate reasoning, and the final explicit answer. And if it is yes, then we have a 1, and if not, it's a 0. So we are in a binary decision. I mean, it couldn't be easier. Come on. And after we have done this, so we have our RAR and our RVR reward, the total reward is calculated for a reasoning path obtained by summing the reward. And then we calculate our advantage here for each reasoning path within a group relative to the group, calculated relative to the average reward of that group, ensuring effective policy optimization. Couldn't be easier. And then the policy model is updated using here the classical GRPO, stabilizing the training and promoting here some credible improvement in the reasoning. And we optimize the policy model with a loss. And I told you I show you here the loss function. This is it, the loss function for this particular case. And here we have our Kullback-Leibler term. And if you do not understand what these terms mean, I have a particular video where I have an introduction to AI mathematics explained in the easy way. This is here the video for you. Otherwise, we just go here a way that we know. Yeah, at the end, of course, we want to have a look at the benchmark. Show me the benchmark. So we have a lot of different benchmarks. Go for whatever you want. At the end, we have an average one. And then we have here the closed source model, then the open source model, then we have here the reasoning models. But I think for us, the most interesting are the last 6 lines here. So you see we have a 2 billion version and we have a 7 billion version. Now, what's interesting is they went, and now this explains why they went with a QN and not a QN 2.5, because they want to be comparable to other studies. And we have another study on a QN 2, a 2B, then we have a 2B with the classical GRPO from R1, but not optimized for multimodal, for this STEP-GRPO. And then we have here what they call R1, but careful, it is not from DeepSeek. This is just an R1-like model, vision language, a 2B. And you see here the benchmark data. Now let's have a look at this, because I see if you just look here, the overall, you see the classical QN2 gives us here this result. If we go with a GRPO, the incremental it's not really famous. And look, if we go for the 7B, if we do GRPO, we even lose performance. But then, of course, If you go here for this R1, like with the STEP-GRPO, the new methodology here in yellow, you see, oh yeah, there is now an improvement here in both cases, in our 2 billion and our 7 billion free trainable parameter. So they ought to say, so we have trained now an R1 VL2B and an R1 VL7B. Great. Just want to show you here the comparison now in detail. Let's say I give you this image and I have a question. I say subtract all the red things you see in the image, plus subtract all tiny mud balls that you see. How many objects are left? So if you say, okay, this is it, and we subtract here the red ball, great, and then we subtract here tiny mud balls, so this is this one. So those 2 balls are gone, so we have 1, 2, 3, 4, 5 objects left. Correct answer is 5. Yes, we have a human who is validating this. But if you now look for the classical Q12, the 7B, you see there's some incorrect reasoning, or if you go with a mulberry, there's also an incorrect reasoning. And it is really, what a surprise now, that this new methodology, the R1 VL7B, what we just discussed here, you see step-by-step reasoning, this is now really provided with some reinforcement learning, the correct result. Interesting, you have a lot of more data in the study. Have a look at it. I think it gives you the technological development vector into the future here for more complex model, for human robotics model, vision language model, and vision language action models. Unfortunately, because it was just published yesterday, if I have a look here at the GitHub repo, they're just starting to fill it up. They just wrote the README file yesterday. They say it will come soon. So maybe when you see this video here, when I record it, you will already have more data than I do have right now. And here we are. So interesting. This R1 model has an impulse here in the open source community. It is just amazing. And now here, even open source, we are trying to develop here the next step, like we saw yesterday with NVIDIA here. Robotics is coming, physical AI is coming into our real world. And of course, we need here not just the reasoning model, but a reasoning model that is able to understand here the outer, the external world model and have an internal world model, compare it here. And therefore, we need here this advanced GRPO, especially in the easiest case possible with 2 reward functions that could not be easier. And the simplest case here, our first experiment here, is a STEP-GRPO. And you see how simple it is to have some AI advancement even today here at mid-end of March 2025. If you subscribe, you will be surprised by my next video.